Okay, hello everyone. So this is the continuation of our discussion on derivatives of logarithmic function. So let me go over the solution for these numbers here. We have for the first one, because these are exercises, but let's solve these numbers here. So let's start with number 1. So for number 1, let's solve it on this side. We're given g of t is equal to 4 times the log of t to the base 3 minus ln of t. So here we have to solve for the derivative for the first term. Hold on. G prime of t. Okay, so we have to get the derivative of 4 times the log of t to the base 3 and then the derivative of ln of t. So we have here a constant. So we have a constant here times this one. So we use here copied. What do we do if we have a constant times a function? So we copy the constant first and then we multiply that by the derivative of log of t to the base 3. And how do we find the derivative of the log of a number to any base a? So we use here which one? Again, let's write the formula. So we use here the derivative of the log of u to the base a. And we say that that's 1 over u times the log of e to the base a times du dx. So here we only have t as our u. So the derivative is 1 over t times the log of e to the base 3 times the derivative of t, which is 1. Then minus ln of t. Again, what's the derivative of ln of t? It's 1 over u. So 1 over t times the derivative of t, which is 1. So we get here 4 times the log of e to the base 3 over t minus 1 over t. Alright, so again, 4. So we have 4 minus. So what's the next step now? So we can simply both the denominators are t. So therefore, we can simply add the numerator. So we have 4 times the log of e to the base 3 minus 1 over t. Okay, then let's do number 2. For number 2, we have 10 to the h of v is 10 to the v log of v. So our variable here is v, parang ganito. H of x is 10 to the x times the log of x. Right? So how do you find the derivative here? What's the formula? We use what? Derivative of product. You have this as u and this as v. This is the derivative of u times v. Again, we copy which one? We copy u times the derivative of v. So 1 over the log of u to the base a. What's the base here? It's understood to be 10. So 1 over v times the log of e to the base 10, you may not write it down, times the derivative of v, which is 1. So this is u. Hold on. This is actually u. And this is what? dv. Now plus, let's just put the plus here. Hold on. Plus, which one? We copied the log of v to the base 10 times the derivative of 10 to the v. So how do you find the derivative of 10 to the v? We use here what? Derivative of a to the u. So it's a to the u ln of a times the derivative of u with respect to x. And here, you have a to the u. Your a is 10. This is a. And this is u. So the derivative is what? A to the u, so 10 to the u. Sorry, 10 to the v. 10 to the v ln of 10 times 1. Okay, so if you simplify, let's simplify it and let's continue here. So it gives you what? In the numerator, we have 10 to the v log of e over v. So again, 10 to the v log of e over v plus plus what? The log of v times 10 to the v ln of 10. Okay, so check if we have a common factor. Do we have a common factor here? Yes, we have 10 to the v is common. So we factor out 10 to the v. So we'll have no, hold on. I should not write this down. Okay, so we factor out 10 to the v. So what's left in the first term? You have the log of e over b plus 10 to the v is factored out. So what's left is log of v times ln of 10. Okay, so there's no more common factor, but we can find the LCD. So what's our LCD? It's v. So we have, hold on, dito. We first write which one? 10 to the v, and then we get the least common here, which is v. So we have the log of e to the base 10 plus what? V log of v times ln of 10. Alright? That gives you your final answer. So that's for number 2. Let's do number 3 on this side. Let's just do number 4. Let's skip number 3. So for number 4, we have f of t is equal to what? 1 plus 5t over ln of t. Okay, so what do we use here? We use the derivative of quotient, derivative of u over v. It's v du minus u dv over v squared. So what's f prime of t here? We'll have, this is what? This is u and this is v. So we copy v, which is ln of t, times the derivative of 1 plus 5t, which is 5. Then minus u, copy u, u is 1 plus 5t, times the derivative of ln of t, which is 1 over t times 1, over ln of t square. So if you simplify, we get first the least common in the numerator. So what's the least common? It's t. So we get here t, or 5t, times ln of t minus 1 minus 5t. Then we multiply, this is your numerator, so you multiply this by the reciprocal of the denominator. And so if you simplify further, this gives you 5t ln of t minus 5t minus 1 over t times ln of t square. Okay, so that's number 4. Okay, you continue with numbers 5 and 6. So do 5 and 6 and 3. I skip also 3. So I did numbers 1, 2, and 4. Okay, now the next is the derivative of trigonometric functions. For trigonometric functions, these are the 6 basic trigonometric functions. Okay, sine, cosine, tangent, cotangent, secant, and cosecant. And that we have these properties which we get from the squeeze theorem. And then this is how we get the derivative of sine x. And we use here the four-step rule. So we may just skip this part. Then this one too. And we get the summary here. This one. So I showed this also already from, this is in your, what do you call this? This is in your BB. And it's also here in OneNote. Look, I put it here. This one. Okay, here. Okay, so again, let's go over this one muna. So, I discussed this already that we have here the following, the derivatives of trigonometric function. For derivative of sine, we have cosine u. Derivative of cosine is negative sine u du dx. For tangent, it's secant square u du dx. For cotangent, negative cosecant square u du dx. And that for secant, secant u tangent u du dx. And for cosecant, you have this one. Alright, so let's go back to this one. Alright, so hold on. Okay, so hold on. Malayo. We have this derivative. Okay. So this one is the derivative of sine x. If you have x here, pero if you have u, you follow these patterns here. Okay. So you may not use this anymore. Just because this is only when we have x. This side here is when we have x. But this is in general. Alright, so then let's have examples. Okay, so again, we may write here, find the, okay, hold on. The question is find the derivative and simplify. Okay, let's have the first example. For number 1, we're given f of x is x to the 4th minus 6 sine x plus 2 tangent of x. Okay, so what's our derivative? We find the derivative of each of the terms separately. So what's the derivative of x to the 4th? That's 4x cubed. Minus, now here you have a constant times this one. So we simply copy the constant term. That's negative 6. And what's the derivative of sine? It's cosine of x times 1. Plus, again, we have here a constant, which is 2, times the derivative of tangent, which is secant square x times 1. Then we simplify. So, we have 4x cubed minus 6 cosine x plus 2 secant square x. Now, if you're going to analyze, we have to express all in terms of, say, cosine or secant only. But from our identity, we say that, that's why I told you, you have to change all in terms of one function only. We know that we could write secant square or secant square x as what? 1 over cosine square x. So we write this as 4x cubed minus 6 cosine x plus 2 over cosine square x. So by using the identity secant square x is 1 over cosine square x, we're able to change this into one function only, cosine lang. And then we get the least common. So what's our least common here? The least common is cosine square x. And then we have 4x cubed cosine square x minus 6. Hold on. Minus what? 6 cosine cube x. Because you have here cosine x times cosine square. It's cube. And then plus 2. So this is your simplified form. Okay? Okay, how about the next one? For number 2, oh, it's here. I have a space here pala. Anyway, this is already, the solution is shown already. Okay, let's do this one. The next is sine of x cubed minus 2x. So what's your y prime? So this is u. So what's the derivative of sine u? It's cosine of x cubed cosine u times the derivative of u. So again, the derivative of sine is cosine. Cosine u times what? 3x squared minus 2. And that's the derivative of x cubed minus 2x. Now, can we multiply this too? No, we can't, because this means cosine of this one. So when you simplify, you could write this as 3. This could actually be the final answer already. Or you could write it as 3x squared minus 2 times cosine of x cubed minus 2x. Alright? Questions on this one? I'm sorry. Okay, the next is g of t is cosine of t cubed times e to the t cubed. Alright, so here, what formula will you use? Derivative of cosine. And the derivative of cosine is negative sine. Alright, so here, this is u. Okay, so what is the derivative, or what's g prime of t? Cosine u. So you have what? Derivative of cosine is negative sine of u, which is t cubed times e to the t cubed. So, times what? The derivative of u. So again, what's the derivative of cosine u? It's negative sine u du dx. So, here we need to find the derivative of u, which is t cubed times e to the t cubed. So we use here, how will you solve for this derivative? We consider this as u and this as v. So what's the derivative therefore? We use here what? Derivative of u times v. U dv plus v du. Okay? So our u is t cubed times the derivative of e to the t cubed. E to the u. So the derivative is e to the u times the derivative of u, which is 3t squared. Then plus e to the t cubed times the derivative of t cubed, which is 3t squared. Alright, so we get here negative sine of t cubed times e to the t cubed times, here we can factor out for this one, because we can factor out here which one? T squared is common, right? Because t squared is common because you have here t cubed and also here we have t squared. So we can factor out t squared. What else? And e to the t cubed. So what's left here? So this is already out, t squared, and this one. So what's left is 3t cubed. 3 is left, and this one. And then here e to the t cube is out, right? And then this t square. So what's left is simply 3. Okay? So this could actually be your answer already. But we could also write this in this manner. G prime of t is equal to, we can first write this one. So we have t square times t cube times what? 3t cube plus 3 multiplied by sine of t cube times e to the t cube. And you have the negative sign in front. Okay? What happened? This is the correct, this is the final answer. How about, here. 3t cube, 3t square, hold on. We should get the same answer. What happened? So this is sine, we're done with this. We have this one already. Sine of t cube e to the t cube. And then, we have 3 because here, so we still can factor this out. Kasi dito, but let's have an or. Kasi pwede namang mag-stop na dyan. So, g prime of t, here kasi we can factor out 3. Okay, hold on. We can factor out here 3. So, if you factor out 3, you have negative 3. Okay? Then, t square times t cube. Is that t cube all? E to the t cube. I did something wrong here. That should be t square times e to the t cube. Alright, so if we factor out 3, we'll have t square e to the t cube times t cube plus 1 times sine of t cube e to the t cube. Parehas na ba? 3t square, yeah. T cube plus 1, yeah. It's the same as this one. So, it could be an or. It means you can stop on this one, pwede na rin dito. Okay, but this is the final answer with the final, the one with the factored form. No more common factor because here we still have a common factor. Alright, let's go over number 4. So here, how do we find the derivative? So we use here derivative of product. Kasi this will be your u and this is v. So we copy u, cosine x. Derivative of sine is cosine plus sine x, and derivative of cosine is negative sine x times 1. Alright, so this gives you cosine square x minus sine square x. Now, as I mentioned, dapat you only have one function. Here, it's either only sine or cosine only. But from our squared identities, we say that sine square x plus cosine square x equals 1. So if we change into all cosine, we solve for cosine square x, which is 1 minus sine square x. So we replace cosine square x by what? Replace this by this value. So 1 minus sine square x minus sine square x, which gives us 1 minus 2 sine square x. Okay? So that's your answer for number 4. Okay, for number 5, what's y prime? So we use here e to the u. And the derivative is what? E to the u times the derivative of u. Derivative of e to the u is e to the u du dx. Alright? So e to the u times the derivative of u. This is your u. So your derivative is 0 minus the derivative of cosine is what? negative sine x times 1. So this is e to the 1 minus cosine x times sine of x. Or this could be sine of x e to the 1 minus cosine x. Any will do. Okay, we still have one more. So how many numbers do we have here? We actually have 7. Huh? Yeah, so let's go over the next one. What happened? Did you get the same answer? E to the 1 minus cosine x. What happened? Cosine of x. Hold on. E to the u. E to the 1 minus cosine times the derivative of this 0. Yeah. E to the u du dx. I think this is not correct. Because cosine x plus sine square x. Right? So this is the final answer. Okay, let's go over this one. So for this one, what is h prime of v? So this actually can be written as what? Ln of what? Sine of v minus cosine of v to the 1/2. Diba? And then by the laws of logarithm, we could write this as 1/2 ln of sine of v minus cosine of v. Bring down the exponent. So it's easier to differentiate this one rather than this original problem here. So how will you find the derivative of this one? We can copy the constant term times the derivative of this. So we copy 1/2. What's the derivative of ln of this? Is ln of u. Hold on. This is ln of this is u. So the derivative is 1 over sine of v minus cosine of v times what? Ln of u. Again, what's the derivative of ln of u? 1 over u du dx. So we copy the constant. Derivative of ln of u is 1 over u times the derivative of u. Now, to find the derivative of this u, derivative of sine is cosine of v times 1. Derivative of sine is cosine minus the derivative of cosine is negative sine v times 1. So this is equal to 1 over 2 times sine v minus cosine v. Then in the numerator we have, times cosine of v minus plus sine of v. Cosine of v minus. So if you simplify further, this gives you, we could find the LCD. So how did you get this one? Because we have the formula that sine of 2v is 2 sine v cosine 2 sine v. Hold on. Sine of 2v is 2 sine v cosine v. Alright, so what is done is we first solve for the LCD. So what's the LCD here? So our LCD, okay. The LCD is 2 times sine of v minus cosine of v. Then, it's not actually the LCD because we multiply this. So we have cosine v plus sine v. So then, what happened? H prime of v is cosine square v. So what we do, you may not do this anymore. You may just stop on this. Kasi for us to do this, we have to manipulate this function. So that will get cosine square v plus cosine v plus 1 over sine of 2v. Mahaba yung solution. Because we'll be using here, this actually, okay, hold on. This actually will give you yung formula that sine of 2v is 2 sine v cosine v. This is the double angle formula. Okay, so you may stop on this. Alright, next. For this one, again, what formula do we use here? This is under the radical. So this is, you'll have to use here the derivative of the square root of u, which is what? Du dx over 2 square root of u. So y prime is equal to what? Hi, hold on. So y prime is equal to what? We find the derivative of u first. So ano yung derivative ng u natin? How will you solve for the derivative? This is u. But to solve for the derivative of u, we use derivative of quotient. Because you have there u over v. So v du minus u dv over v square. So we get here what? In the numerator, kasi du dx ang numerator. Let's do copy 2 square root of u. So 2 square root of u is 1 minus cosine x over sine of x. Okay, tapos sa numerator is the derivative of 1 minus cosine x over sine x, derivative of u. So we have here, hold on. Okay, so let me just use this. So in the denominator, you'll have sine of x squared. So v times the derivative of u, 0 minus sine of x. Then v du minus what? U, which is 1 minus cosine x times the derivative of sine x, which is cosine x. So v du minus u dv. Then we simplify. So again, the numerator will give you what? Positive sine square x. Right? 0 minus minus. And then we distribute this here. So it's what? Minus 1. Then this and this one will give you negative cosine square. But you have here negative, so plus. So it should give you plus cosine square x. Minus 1 minus minus plus over, this is actually sine square x. And then the denominator can be written as 2 square root of 1 minus cosine x over sine square root of sine of x. We still have space. Yeah. Meron pa. Okay, so how do we simplify this? We can simplify this further. Now look. Sine square x plus cosine square x equals what? 1 minus 1. What happened? Naging 0. Ulit. V is sine x, derivative of cosine. This is 1 or 0 minus negative sign. Minus U. U is 1 minus cosine. Okay. Then minus minus. Minus 1. So this becomes, what happened? Nag-zero siya. Because sine square plus cosine square is 1 minus 1. Okay, hold on. Okay, so let's continue. Okay, so there is something wrong with this one. That's why we get 0 here. Let's remove this one. Because here, if we distribute, hold on. If we distribute cosine, so look, for the first one, we have sine x times sine x, it gives you sine square x. And then, when we distribute this one, it should give you, it's red again. It should give you negative cosine x minus minus plus what? Plus cosine square x. Right, so when you distribute this one, cosine x plus cosine square x over sine square x, and so this now is equal to what? And so this gives us, in the denominator, we have, what happened? We have a 2. We could write it as 2 times what? 1 minus cosine x over sine x to the 1/2. So we could write this as 2. Let's try. 1 minus cosine x over sine x to the 1/2. And if you simplify further, this gives you sine square plus cosine square x gives us 1, right? Which when you combine this and this one, it will give you 1 minus cosine x, right? Over sine square x. And then we divide by what? We divide by 2 times, we could write this as 1 minus cosine x. Oh, I could write it this way. Hold on. It can be written as hold on. The numerator is now 1 minus cosine x to the 1/2 over sine of x to the 1/2, which can be written as what? One minus cosine x over sine square x times the reciprocal of the denominator. So it's 2 times 1 minus cosine x to the 1/2 over sine of x to the 1/2. Alright, so 2 must be, because it goes with, hold on, this goes with the numerator, right? So baligtad. Two times, dapat in the numerator we should have baligtad. Mali ito. This should be what? Reciprocal. So what's the reciprocal? The reciprocal of the denominator is which one? Sine of x to the 1/2 over 1 minus cosine x to the 1/2 times 2. And so, if we simplify, this is equal to what? 1 minus cosine x to the 1 minus 1/2 times what? Sine x to the 1/2 times sine, okay. Sine square x can actually be written as sine x squared. Then 2 should be in the denominator, divided by, what happened? This one has a, yeah, divide this by 2, because 2 is left in the denominator. Sine, okay. So if you simplify, this gives you, this is actually 1 minus 1/2 is 1/2. So we have 1 minus cosine x to the 1/2. And this gives us sine of x to the 1/2 plus 2. 1/2 plus 4 over 2 is 5 over 2. What happened? We did something wrong again. Hold on. Because you have 1 minus cosine x over sine square over 2 times 1 minus cosine x to the 1/2 over sine x to the 1/2. So if you simplify, we get what? To the 1/2. 1 minus cosine x over sine square x is correct, times the reciprocal of the denominator. So 1 minus cosine x to the 1/2 is right, times 1/2 plus 2, it's sine square. So sine square, hold on, sine to the 1/2 should go in the numerator, because we get the reciprocal of this. So sine to the 1/2 no, this is wrong again, hold on. So 1 minus cosine, sine, this should be what? I did something wrong here. This should be sine x to the 1/2 minus 2, right? Because you have 1 minus cosine x, this is to the first, so 1 minus 1/2, 1/2 minus 2 over 2, right? So then This is, you have 1/2. 2 is 4 over 2. So negative 3/2. Alright, over 2. And so if you simplify, this is now 1 minus cosine of x to the 1/2 over 2 sine of x to the 3/2. And if you simplify further, this gives us what? You could just simply write this as what? The square root of 1 minus cosine x over what? 2. Then the square root of sine cube of x. Or we could write this as, pwede na rin ng 1/2 of the square root of 1 minus cosine x over sine cube of x. Alright? So that's your y prime. Okay? The next problem is, we may not use this anymore because this actually, the solution will make it long. Because we use here the value that 1/2 of y cosecant x. So no, we don't use that anymore. That's we'll discuss that when we go to implicit differentiation. Now, the next is this one. You still have a space? Alright, let's just try one or two examples here. Let's do number 2. So for number 2, we are given y is tangent of x to the 4th minus 4. So what's your y prime? This is u. The derivative of tangent u is what? Secant square u. So therefore, this is secant square of x to the 4th minus 4 times 4x cubed. That's the derivative of what? Tangent. Again, let's write the formula. The derivative of tangent u is secant square u du dx. Right? So secant square u times the derivative of u. And if you simplify, this is simply 4x cubed times what? Secant square of x to the 4th minus 4. And then, let's do number 3. So for 3, you're given g. Let's use g of x. G of x is e to the secant x minus cosecant of e to the x. And this is raised to the 4th. So what formula will you use first for this one? So we use here the derivative of u to the n, which is nu to the n minus 1 du dx. Because here, this is u to the n. So what is g prime of x? You have 4 times e to the secant x minus cosecant e to the x raised to the 4 minus 1 is 3 times the derivative of e to the u. So we use derivative of e to the u is e to the u. Derivative of u is secant u tangent u times the derivative of u, which is 1, derivative of x. So e to the u du dx minus the derivative of cosecant is negative cosecant square of e to the x times what? Ulit. We have the derivative of e to the secant x is this one. Okay? Times the derivative of cosecant e to the x, which is cosecant square e to the x, hold on, let's change this. So again, times the derivative of, or minus the derivative of cosecant, which is negative cosecant square u, this one, times the derivative of e to the x, which is e to the x times 1. Alright? Cosecant u times the derivative of u, which is e to the x times 1. And then we simplify. So this gives us 4 times e to the secant x minus cosecant e to the x cubed times, do we have a common factor here? Yes. Do we have e to the x? Is not common. Cosecant is not. So we have here e to the secant x tangent x minus minus plus. We could write first e to the x times 1. We may not simplify this anymore kasi there's a lot of variables to change into one function only. Alright, now let's try number 7. So h of y is, hold on, cosine square of sine of y. So take note that for this one, we don't have a formula when this is squared. So we could write this actually as hold on, cosine of y, sorry, it's cosine of sine of y is squared. Kasi take note that if we have sine square x is the same as sine of x is square. So if you have cosine square x, it's the same as cosine of x squared. So this is cosine square sine y is the same as cosine of sine of y squared. So what is h prime of y? You have this raised to the u. So we have n times cosine of sine of y to the 2 minus 1. So it's to the first. Times the derivative of this one. So you have here cosine of u. The derivative of cosine of u is negative sine of u. Let's use a different color. So the derivative of cosine of u is negative sine of u, which is sine of y, times the derivative of y, which is 1. Again, cosine of u, the derivative is negative sine u times the derivative of sine. Oh, it's not 1. It should be what? Again, cosine of u, this is your u. Derivative of cosine u, sine of u times the derivative of sine of y is cosine of y times 1. So this is 2 cosine of sine of y, negative because of this one. And then you have sine and sine of y times cosine y. So that's h prime of y. Alright? So take note that, say we have this one. Let's have an additional problem. Say we are given y is secant to the third of x plus 1. Let's have x squared plus 1. So this is actually the same as what? We don't have a formula for secant cube. But we could write this as secant of x squared plus 1 raised to the third. So our y prime is 3. You use here u to the n. So n times what? secant of x squared plus 1 and u to the n minus 1 times the derivative of secant, which is what? Secant of x squared plus 1 tangent of x squared plus 1 times the derivative of x squared plus 1, which is 2x. Alright, so if you simplify, this is 3 times 2x gives us 6x. 6x, then secant squared times secant is secant to the 5th of x squared plus 1. Because you have here 2 and 1. Sorry. Secant square times secant. It's just cube. Sorry. It's because you have here secant square times secant. So it's secant cube. Then times tangent of x squared plus 1. Alright? Now, we're supposed to express this all in terms of tangent or all in terms of secant, but you may just leave your answer this way. Because remember, we have a formula that 1 plus tangent square x is equal to secant square x. So, magkakaroon pa tayo ng square root. If you want to solve for tangent, is secant square x minus 1. And then to solve for tangent, becomes secant square x minus 1. So, you may just leave your answer this way. Alright, so that ends the lesson on transcendental up to trigonometric function. So our next screen recording will be about derivative of hyperbolic, inverse hyperbolic, and inverse trigonometric functions. Alright, bye-bye.